Good afternoon and good morning if you're joining in from the Americas, and good evening if in South Asia and beyond. On behalf of CPI Industry, publishers of Climate Control Middle East magazine, and the online platforms climatecontrolme.com and climatecontroljournal.com, it is my absolute pleasure and privilege to welcome you to the fourth edition of Refrigerants Review. My name is Surendra Balakrishnan, and I'm the editorial director and co-founder of CPI Industry. Nowadays, it is impossible to start any webinar without a reference to COVID-19. Now, some of you might wonder what the reference to COVID-19 has to do with a webinar on refrigerants. But we have gathered here to discuss under the theme, how to avert a dangerous global warming feedback loop. Now, according to the authors of DNVGL's Energy Transition Outlook, COVID-19 has significantly altered our economic and social behavior to such an extent that it has profoundly reduced global long-term energy demand. According to them, COVID-19 has also hastened the decline in carbon dioxide emissions, with 2019 set to be the year of peak CO2 emissions. Compared to DNVGL's pre-pandemic forecast, the amount of energy required by humanity in 2050 will be 8% lower. Lasting behavioral changes to travel, commuting, and working habits will also decrease energy usage and lessen demand for fossil fuels from the transport sector as well as from iron and steel production, the authors of the report said. This is what Remy Eriksson, who's the CEO of DNVGL, had to say, and I quote him, "We are still at a critical junction. We basically have the technologies to deliver on the Paris ambition, but we need smarter policies to scale these technologies much faster. COVID-19 has caused enormous human suffering, but has at the same time shown us that measures can be implemented fast at scale. This is an opportunity that cannot go to waste. Governments and international regulatory institutions must take this opportunity to make a lasting impact on decarbonization," unquote. According to the DNV report, demand from the transport sector will never reach pre-pandemic levels due to the downturn in the aviation sector and because of altered commuting habits as people work from home more. In turn, the energy-intensive process of iron and steel production will be hit by a reduced demand for office space. With the earlier than anticipated plateauing of oil and the continued rapid decline of coal use, DNV's forecast shows that CO2 emissions most likely have already peaked in 2019. However, even with peak emissions behind us and flat energy demand through to 2050, the energy transition is still nowhere near fast enough to deliver on the Paris ambition of keeping global warming well below 2 degrees centigrade above pre-industrial levels. To reach the 1.5 degree target, we would need to repeat the decline in emissions we are experiencing in 2020 every year from now on. To put this in perspective, the COVID-19 impact on energy demand only buys humanity another year of allowable emissions before the 1.5 degrees centigrade target is exhausted in 2029. And it buys us 2 years before the 2 degrees centigrade warming carbon budget is exhausted in the year 2050. And so, all of us gathered here must continue our efforts in the widespread and safe use of low global warming potential refrigerants that also protect the ozone layer. We have a deep responsibility towards achieving that goal. And on that note, it is my privilege to introduce you to the chairperson of this very important webinar, which, by the way, has attracted delegates from nearly 30 countries at the time I last received the registration report from my colleagues in CPI Industry. Ladies and gentlemen, it is my pleasure to introduce you to the chairperson, Yaqub Al-Matouk, who in many ways does not need an introduction, considering he is a popular figure in global refrigerant conferences. Yaqub is head of ozone section at the Environmental Public Authority in Kuwait. He served as the president of the 29th meeting of the parties to the Montreal Protocol. His involvement with UNEP started in 2003 as a refrigeration expert in the Kuwait National Ozone Unit and as a member of the Kuwait National Ozone Committee. He participated as a lead negotiator for the GCC region in the Montreal Protocol, as a coordinator of A5 countries comprising 148 countries, as a coordinator for the Asia Pacific Group region, and as a member of the Executive Committee for the Multilateral Fund. He also served as a refrigeration consultant in several UNIDO and UNEP projects in the Middle East. Ladies and gentlemen, I present to you Yaqub Al-Matoub.
Assalamu alaikum. Peace be upon you, everyone. Good afternoon, good morning, good evening, wherever you are. First of all, let me thank you for participating with us, taking a time from yourself, giving us a chance to connect with you and to share thoughts and like this. I would like in the beginning to thank Surinda and Alkana, our friend, for giving me the chance again to be joining with this tremendous people and good, well-known people in that field and in that sector. Actually, it's a pleasure for me to be here with you within this time where we can say that nothing can stop us as a human being to act and interact. Yes, we are in a pandemic, and yes, we have issues and we have safety issues as a human to take care of, but that cannot stop our mind, our thoughts to do our jobs and to give the best we have in the best way that we can do. So as you know, that refrigerant review is a chapters of our life that started from long time story, taking into account to review the refrigerant and how they are dealing with us, especially in the Middle East and in our region in GCC. The added value of that refrigerant review is sharing the knowledge, sharing the worries, also sharing the question and sharing the things that we need to solve, understand, or to commit. Our plenary and our sessions today will be, as you see in the agenda in front of you, or it's being sent to you, that we have two presentations and a panel discussion, and this panel discussion with a group of people that they are expert in their field, they are much knowledge, they can give you a lot of roadmaps for yourself, for your company, for your country, how to go and move. And also our colleague from UNIDO, they will share with us success story of their achievements in our region and different region, but that will give us a movement or a place to put our train in the track to move. Saying that, I just want to say that when we talk about refrigerant and when we talk about the refrigeration, when we talk about refrigerant and refrigeration and home and GCC countries, this is a necessity of our life. And when we say necessity, it's not a luxurious way to have an air condition. It's a necessity to have a cold air so you can act and react on anything in this life. The chain that the GCC use is a big chain. We are talking about food preservation. We are talking about vaccines, medicine. We are talking about lifestyle that we have. We are talking about home styles, everything, even our transportations is connected with refrigerant and cooling systems or air conditioning systems. In Montreal Protocol, we spend almost 33 years now dealing with the environmental issue and the effect of these refrigerant and these technologies which contain these refrigerant. Finding answers, finding pathways, finding solutions whenever we can keeping the remaining where we need a little bit of time, not to stop us, than doing the best we can do. I don't want to speak as much to give the chance for my friend who will join me in this refrigerant review. And as I told you before, that we will go through a presentation that will be presented by the distinguished delegates, Franziska Minta. She's a good friend of mine from UNIDO. We have a lot of things sharing together. She's the most experienced one. She likes the Middle East so much, and she attend a lot of places with us. And as I always say to her, and maybe she feel always shy when I say this to her, she have one of the most important smile to give you an achievement in your life. So when I introduce my colleague, I just want to say that Franziska Minto is a project coordinator, Montreal Protocol Division Environment Department at UNIDO in Austria. She has more than 10 years of professional experience in the field of climate and climate-friendly technology in the air conditioning and heating and refrigeration systems. She worked with the private and public sector at UNIDO. She is working on the development and implementation of a project related to Montreal Protocol and the phase down of HFCs. The key objective of the project is to establish partnership and facilitate investment for supporting the introduction of innovative, sustainable, and energy efficient technology, as well as practice in developing countries. Franziska, you have the floor, and I'm sorry if I don't pronounce your name in the good way, but keep it in your mind that we will learn it from you. I will say that we will give you a 10-minute sharp for your presentation. Thank you very much.
Thank you very much, Jakub, and you pronounced it perfectly. And yes, it's very nice to see you virtually again. Hopefully we can all meet again in person, well, relatively soon, but I think until then it's also a very good opportunity that we have here and to meet regularly, and I think we should continue, and I think it's a very good opportunity. Thank you very much, Jakub. Thank you very much also to the organizers, CPI Industry, and thank you very much to all the participants for joining here, and I hope we can do that on a regular basis now. So I will share my screen with you. I hope that this works as planned. Just give me a second. Very well. So, salam alaikum. Hello, good morning, good afternoon to everybody again. And thank you for giving me also this opportunity and the chance to present today to you what I find a very interesting project of the first CO2 supermarket in Jordan, which is, as you know, a country also defined as high ambient temperature country, a head country. So I believe the facts and figures of that demonstration project that I can share with you today show very promising results of that environmentally friendly technology, and can also prove that this is a viable alternative in many regions, including warm countries. But maybe just quickly, thank you to Jakub again. You introduced me already. My name is Franziska. I'm a project coordinator in UNIDO. I'm based in the headquarters in Vienna, Austria. All fine here. We are all safe and sound. I hope the same for you. The weather is rather mixed, so I hope that for you the sun shines on you and all your cooling devices work efficiently and sustainably. I have started adding a few slides about UNIDO that I will skip now, but you can just read them later, and I don't want to delay the webinar any further. So let's jump right into it. Just a few facts first. The project finished last year, and it was a demonstration project to demonstrate a non-HFC alternative to HFC 22 in retail installations in countries with high ambient temperatures. It was funded by the CCAC, the Climate and Clean Air Coalition, and we work closely with the Ministry of Environment in Jordan. The goals of the project were the full replacement of an old R22 refrigeration installation to a CO2 transcritical in a supermarket, and also, of course, to share the results widely, of course, with the ultimate expected result to see if the chosen technology is a viable solution for the region. The total budget was $605,000 US. So now to the project side and the technology. The system that we have chosen through technical assessment of international experts involved, the National Supermarket and the government, were the state-of-the-art CO2 transcritical system with parallel compression and multi-ejector technology to ensure energy efficiency in the high temperature environment, of course. The supermarket where it was installed was the Al Salam Supermarket in Amman, which is Army owned. The technology provider we worked with was a beautiful teamwork actually of the national supplier called Abdeen, a cabinet manufacturer and system installer, and an international pioneer in CO2 called Annex. Here we see the layout of the final system, a CO2 transcritical booster system with parallel compression. To ensure the high efficiency, also during the high ambient temperatures in the summer months, the system integrates state-of-the-art ejector technology. The system features also non-superheated evaporated technology for both the chilled and the frozen food cabinets and storage rooms. The waste heat from the system can be recovered for hot sanitary water supply, which saves then further energy overall. Just quick technical additional facts. The net capacity on the medium temperature side accounts for 31 kilowatt and the gross capacity 69 at -2 degrees Celsius. The low temperature capacity amounts to 38 kilowatt at -25 degrees Celsius. The technology supplier of the project mentioned before is Abdeen Industrial. It's a 100% Jordanian family-owned company which provided the 4- and 5-door cabinets, set up all the piping, finalized the on-site installation. And the company worked closely with the Italian-based international system manufacturer Annex, who supplied the refrigeration system. Now here we can see the heart of the system, the CO2 rack and the gas coolers that are located outside of the building. And I will also show a few pictures more if we have time at the end of the presentation. But let's jump right into the results in regards to the energy, first of all. So here the graph shows the monthly energy demand for the year prior to the CO2 unit installed, which is the I hope you can see my mouse, which is the first part in 2017. And then once the CO2 unit was installed in February 2018, when the measurements started here until end of August so far. Now, if we zoom into the summer months of the first year of operation, where the experts were still adjusting also the settings, and by the way, everything was also monitored and controlled from a remote system and from experts that supported this project as well, Danfoss in Denmark, supporting the local manufacturer and supermarket. Anyway, already here we can see that there's been a good amount of energy saved despite of the high temperatures. And over the course of a year, taking also into consideration the colder months, this has been very satisfying for the end users. The supermarket. However, the energy results are not the only important measurement, and we also received additional feedback from the end users, which included that, for example, the closure time in the supermarket during installation was 0, meaning that only a part of the supermarket has been closed for 2 weeks to do the installations, but the rest was full functioning and they didn't have any decreases in the profit. So then, which is also important, which we had not really taken into consideration before, is that the food loss decreased substantially, basically to 0, which was before a big problem for the supermarket because of the old system and the unstable temperature levels. Something else which was important, of course, is the energy that we mentioned, which we can average more or less on a 20%. Of course, it's always the question how you measure it and how you compare it to. But in all scenarios that we used and that we have, it was a significant decrease in the energy use. So just to conclude, we can maybe say overall that this is the Middle East first transcritical CO2 refrigeration in supermarket, as far as we know, demonstrating green state-of-the-art technology within the cold chain. Results show that the system is delivering on energy savings, zero food loss, and no maintenance costs in the first year of operation. The green design recovers the waste heat from the system to supply also sanitary hot water, further increasing the system's energy efficiency. Also important that the trained local engineers and technicians have led to better servicing and maintenance and will also extend the system's lifetime. The project successfully tested and validated technology that uses more climate-friendly alternative refrigerants in the challenging conditions. This demonstrates what we can say and what we concluded, that within the cold chain, emissions of harmful substances can be reduced, thus minimizing environmental impact. The system's success has established a better understanding of the applicability of the technology in countries with high ambient temperatures. We hope that we can show this also to you, and promoted innovation within the national industry, which is encouraging follow-up projects in the region. Of course, we also have to mention the challenges, which is the first cost, the CapEx, which is higher, but very importantly, we have to look at the longer term and that the operation costs are significantly lower. I have here put together a few pictures so that you get an idea also how it looked before and how it looked after. So this is the Al Salam supermarket. This is how the system, this outside unit, has looked before. The compressors, the condensing units, here the old chiller units, all just outside of the supermarket. And also these were also, you can see the chilling cabinets inside. And then here, this is an example picture of the actual unit installed then. And this is how it looks at the supermarket in Amman. And here also a few zoom ins on the beauty of this technology and installation and engineering artwork. I have to say, always impressive to be there and to look at it. And this is the inside and the cabinets that have been installed in this system. So I only had, that was just a very quick summary basically of the results of the project, but you can go please and check out our websites where we have a whole technical report with all the technical details, all the direct, indirect savings explained again, a final report also zooming into all of the components that we have used, a little summary video, and if you have any questions, you can always contact UNIDO Montreal Protocol or me directly. Thank you very much. I hope that gave you a little bit of an insight.
Thank you very much, Francisca, and thank you for keeping with the time. And it was a pleasure, and it really was a very nice presentation that I just want to tell people that she shortened this presentation to a limit to keep the time. Rather than this one, there was a lot of information that we have seen before. And I will thank you very much, Francisca. We will come back to you after we have the second presentation. So if any question having to do with this presentation before we start our panelist discussion. So thank you very much. Now we will ask our distinguished delegate with another presentation that we have. My friend is Edgar Pinto. Edgar Pinto is a national expert in the refrigeration at UNIDO, Brazil. He is a mechanical engineer with a master's degree in mechanical science from the University of Brasilia. He is currently pursuing postgraduate in health and safety engineering. The presentation that he will present is a case study also in one of the largest A5 country consuming refrigerant and refrigeration in the world. The presentation is also a success story that UNIDO have done in Brazil. So Edgar, please, you have the floor.
Thank you very much. I will share my screen. So good morning and good afternoon, ladies and gentlemen. My name is Edgar, and today I'll present our experience with propane in 2 supermarkets in Brazil. First, I would like to give a special thanks to my colleagues from UNIDO, the Brazilian Ministry of Environment, Eletrofrio, and Ploterrax who are involved in this project. And also, I would like to thank the organizers of this meeting. Okay. My presentation will be composed of 6 items, which are key stakeholders, project goals, companies, propane and installation chillers, barriers, and key findings. The development of the modular chillers with propane is part of the Brazilian HCFC phase-out management plan. This management plan is coordinated by the Brazilian Ministry of the Environment, and UNIDO is the implemented agency for the RAC sector. All the financial resources for this project implementation are provided by the Multilateral Fund for the Montreal Protocol. The first goal of the project is to replace R22, and there are 3 natural options suitable to replace the substances. CO2, which requires high operation pressure, ammonia, which is toxic, and propane, which is flammable. Our solution was to develop a modular chiller based on propane, charged and sealed at the factory. The system was designated to facilitate its installations and maintenance. It can be installed outside the store or in a machinery room, keeping the propane out of the sales area. Also, the system was designed in a way that potential failures would be limited to only one module, while other models would continue working. For the demonstration activity, it's important to show that this solution is safe and is energy efficient. The project selected Eletrofrio and Ploterrax for this activity. Some years ago, both companies were using R22 as a main refrigerant, and over the years, they have introduced HFCs, mainly 404 and 134A. In recent years, due to the development of CO2 technology, both companies developed subcritical systems and also installed transcritical systems. Today, we have around 30 transcritical CO2 installations in Brazil. Last year, we had the first propane installation, and by the end of this year, we expect 4 installations running with propane. The introduction of propane will cease the production of equipment with HCFCs and has potential to reduce the use of HFCs. To handle the propane safely, both companies received a refrigerant handling package and a couple of safety measures. I would highlight a charge machine, a recovery unit, ATEX ventilation system, sensors and alarms for propane. This is Eletrofrio's assembly area, and as you can see, I will put my laser. We have a charging machine over here, a ventilation system. This is the prototype that they developed. Ultrasonic welding tool. Here we have a leak detector, alarms, audio alarms and visual alarms. And over the floor, we have some sensors distributed. Also, we have an anti-static painting. And this is Ploterrax assembly area, charging area, sorry. As we can see, we have also a charging machine over here, the ventilation systems. We have some sensors below the trays. We have some stop emergency buttons. We have our recovery system, we have the whole solution for keep safe this area. Electrofuel developed a model with a compressor, a condenser, an evaporator, an electronic expansion valve, and a propane sensor. These components, they are located over here, where we have only ATEX components. They are certified to operate with flammable refrigerant. And outside this model, we have an electrical panel where we have some normal electrical components. This model has 1.9 kilos of propane, and it's used for medium temperature cabinets and display cases, and also to condense the CO2 in a subcritical system. There were 6 models were installed in a Condor Supermarket in Brazil. The system was the store was the first store in Latin America to have 100% natural refrigerant. I can say this because they don't have air conditioning in the store. So they have propane for the medium temperature and CO2 for the low temperature. And comparing this store with a similar store in the same city, Electrofuel obtained an improvement of 3% of energy efficiency, and they realized that the system was 5% more expensive. But this is totally acceptable because they bought some companies specifically for this project. In terms of charge reduction, they obtained 94% of charge reduction. And according to CO2 equivalent metric, the impact of the propane in the store is negligible. They obtain a reduction of around 99%. This store also, there is around 15 kilos of propane with the systems, and I will show some pictures of the machinery room. Here you can see 6 models over here, and 2 ATEX ventilation systems. The ventilation systems keep running all the time to keep the system safe. Normally, 5 models are working and 1 model is a backup. Over here, we can see the electrical connections, the ventilation hoses, and the glycol and water connections. If you need to service 1 model, you just unplug the electrical connections, unplug the ventilation hose, and unplug the water and glycol connection. So remove the model, service in the factory, and then return it to the supermarket. This is the prototype that HVACR has developed. It has 1 compressor, scroll compressor, a microchannel condenser, a brazier plate evaporator, and an electronic expansion valve, and a propane sensor. So over here, it's only allowed ATEX components, and also we have the electrical panel with normal components. This model has around 1 kilo of propane. HVACR installed 3 models in a Bahamas store in Brazil. This store, it has around 3 kilos of propane. Regarding the safety, the system efficiency, they are still in a monitoring process, but in their laboratory, they obtained a COP increase around 12 to 15% in partial load when compared to a 410A system. The system is also used to condensate a CO2 subcritical system. Here are the models. They were installed in the roof of the system. The noise level is not too high. It's okay. And here we have our additional rack where some pumps are located and other electrical components are located. Here we can find another picture of the installation. And also I would like to highlight that this installation is in accordance with ISO 5149. As some barriers that we have identified during this process, the first one is regarding about the flammability of propane. And we took all the measures to have a safe solution and to mitigate the flammability risks. For example, each model has a propane sensor it has extra ventilation and has a propane protocol, turn-off protocol to turn off those models in case there is a leak. Another issue was the skills of the services, the service technicians. We developed the project as if there is any issue, they return the model to the factory, maintain it, and return to the supermarket. So by this time, we don't need, it's not necessary a technician trained to handle the propane in the field, only in the factory. But in the future, they might do some service. Another barriers that we found was the cost of the project, because ATEX components and components rated to work with propane, they are a little bit more expensive than normal components, and also they are imported. We don't have these items in Brazil, so we had to import all of them and keep some spare ones in the factories. And finally, I would say some key findings that we found in the project until now. The first one is that propane modular chiller will help both companies to develop a new solution and new business models. We observed improvement of energy efficiency. The systems require less maintenance, a reduced installation time, a safe place to assemble and maintain the chillers in the factory. We observed a charge reduction. At this moment, we don't need trained technicians in the field to service the equipment. With this project, we will raise awareness regarding the advantage of using propane in refrigeration systems. The adoption of the propane will limit the future use of synthetic refrigerant with high GWP. And finally, the project with electrofuel blotter hacks will result in 157 tons ODS elimination. I hope I could help you understanding of the potential of this technology, and thank you very much for watching the presentation.
Thank you very much, Edgar, and I just want to appreciate the presentation that you put in front of us and give us a guidelines on the issue we need to talk. Saying that, before we jump to the panel plenary discussion, I just want to say that all the questions that has been written to us, we will take them in a note, and then in the end of the plenary discussion, where we can open a discussion, question and answer of everything, that we can carry all these questions to the participant itself. So bear with us, Edgar. So we will come back maybe with the panelists. I will raise some question for you. It's been raised to us, and also maybe in the last session, where is the question and answer, that we can again take a group of questions. Thank you very much. Edgar, now you can mute your mic. Thank you very much. So as we are listening to the two presentations about a success story in one of the sectors that refrigerants are covering, as you listen, that UNIDO is the United Nations Industrial Development Organization, which work with us as Article 5 party to develop projects, scenarios, thoughts, sharing idea, technical support. And with UNIDO and with other sister agencies, we, as an A5 party, we achieve a lot. And the biggest achievement that these agencies give us is to keep compliance with Montreal Protocol for the last 33 years. All the GCC countries and all of the A5 countries are in compliance with Montreal Protocol rule and regulation for this. So this is one of the success story that you need to share with the countries. I just want to say now that the plenary discussion will start. And before we jump to the plenary discussion, just want to again recognize the plenary technical people. I will mention them by name to join us in this plenary discussion. First of all, I want to call for Dr. Mu'taz Bakhit. Dr. Mu'taz Bakhit is the director of Zufair Fires Partnership in Saudi Arabia. He's also a partner, advisor, and vice chairman of Bakhit Financial Advisor Riyadh. He has authored various publications and is involved in designing and developing various training courses. He is working in Al Madinah Al Munawwara, and he has a lot of experience in the design and architects of programs, also in developing programs for air conditioning and selection of equipment. He will be one of our panelists. The second panelist with us will be my friend Didier Colombe. And Mr. Didier Colombe, he's from France. He is the Director General of the International Institute of Refrigeration. He worked for the French Ministry of Agriculture and for the French Research Ministry. He was the General Secretary of the CIRAD until 2004. He is a qualified engineer from the École de Paris. I'm sorry, I cannot pronounce it in France, but he can do it. Also today, for a specific condition that happened, that Mr. Mazen Hussein couldn't join us to this meeting. Also, our colleague Francisca is connecting to another meeting, but she will join us later. I think Mr. Edgars is with us, and we will start the discussion panel. I will drive the discussion and the plenary to be advised to talk about, as everyone knows that in this time of this century, as I mentioned before, refrigeration is an issue. But in the last 4 years now, we start something called Kigali Amendment. The Kigali Amendment is transferring us from a basket of refrigerant to go to another basket of refrigerant, taking into our consideration 2 elements. In early 90s until mid of 20s, we were thinking only about the ozone hole and how to get out of all ODS, ozone depleting substance. And we are forgetting and not taking it seriously when we are discovering our future in the refrigeration, to take into account the energy side and the global warming potential that created from developing such kind of technologies and such kind of refrigerant. Just to give you an overview of the type of refrigerant, in ASHRI, which is the institute that they give the R number to any refrigerant, they have on their list more than 100 or 200 refrigerant, new refrigerant they need to be classified. In our region, in the GCC region, and in our aim in the refrigerant review, to review these refrigerant in a different manner this time. We want to see how we can have the fast-tracked movement and how we can jump or have the leapfrog jump, that we go to the end road rather than moving in the middle and jumping in the middle until we reach. The second issue that we have to discuss in the plenary discussion is the safety concern, and also the flammability and the safety of these refrigerant and the equipment depending on these refrigerant, also taking the consideration of the safety of the parameters that these units and these alternative will be used. Another item that it's very important to discuss when we are designing to go through this path is the regulation and the trend and the performance of these alternatives and these refrigerant and the technology associated with. Also, we have to talk about the distinguished delegates that he will cover, and I'm sorry I didn't mention him in my previous thing, that we will talk about beyond the box and out of the conventional air conditioning unit, that when we talk about district coolings and type of refrigerant and safety in this district cooling, that we are having in our region and expanding in our region. This item will be tackled by Mr. Ibrahim Hisham Hussein. He is a mechanical engineer specialized in HVAC system, district cooling plant, and related infrastructure network, from system design, life cycle cost, till construction, supervision, and management. He is a specialist including piping stress and surge analysis, hydraulic modeling, and smoke management. Mr. Ibrahim, welcome with us. I'm sorry if I didn't capture you in the beginning. So we will start now our dialogue with prioritizing our thoughts. So whenever anybody want to have an air condition or to think about the air conditioning and how to design air conditioning in a facility, we have one thing to do in the beginning. We have to talk about the regulation, the trend, the energy efficiency, the refrigerants that we can use. So if countries don't have rules and regulation, then we have a big problem for the industry to adopt and achieve necessarily things to be done. So just welcome with me, Mr. Didier Colomb. And Didier, I will give you the floor now just to interact with us about the regulation, the trend, the energy efficiency, and refrigerant view and trend in the world in the time being. So you have the floor, and we will give you in the beginning like 5 to 7 minutes just to express yourself. Then we will go to another panelist to complete our job. Didier, you have the floor.
Thank you, Jakub. First, I would also mention the fact that now the climate change is the most important challenge. And it's very clear that we will have more and more regulations, stricter regulations and standards on all refrigeration technologies and uses. And I would like first to mention the fact that about 2/3 of the impact on climate change of refrigerated equipment is due to the energy consumption. So we currently have a lot of current or incoming regulations regarding refrigerants, but in the future we will have more and more regarding energy. So first regarding refrigerants, well, in any case, I'm convinced that you now have the Kigali Amendment, but in the longer term, you will have more than the Kigali Amendment. So in any case, you have to respect the Kigali Amendment because we already see some regulations in certain countries in the world, for instance, in Europe, where you have a lot of discussions regarding a stricter phase down or phase out in some applications regarding the high global warming potential refrigerants. So in any case, we cannot wait. In a long-term perspective, there will be almost a phase out of high global warming potential refrigerants. And of course, there will be also regulations regarding safety, because most of the technologies we can use to reduce the refrigerant impact, which is 1/3 of the impact of refrigerated equipment, most of the technologies are using flammable refrigerants, mildly or highly flammable refrigerants. So there is already work which was done at the international level regarding standards for new standards for hydrocarbons, for instance, for flammable refrigerants, and there will be certainly in a certain within the next years implemented in the country. So there will be a place for these refrigerants, even if they are not enough used, not used a lot all over the world. And we had an example in Brazil just before. Regarding the energy, I'm convinced that first, there will be more and more regulations and standards regarding the energy efficiency of the equipment. For instance, you mentioned air conditioning. There are a lot of small equipment for air conditioning. And there is a gap between the most energy efficient equipment and the less ones, a very important gap. So in any case, it is possible to really improve the energy efficiency of the equipment, just forbidding some equipment or labelizing the good equipment. There will be also standards regarding more whole systems, standards on buildings, standards on some kinds of systems which can be replicated. For instance, we had the examples of supermarkets, and supermarket is, of course, a little different, but not so different country by country. So it will be certainly possible to have some guidelines for lower global warming impact with supermarkets, taking into account both refrigerants, but also the energy consumption. And we are currently working with UNIDO also to publish a kind of guide for decision makers, what kind of things which are important to reduce the energy consumption and to use low global warming refrigerants, especially natural refrigerants such as CO2 or hydrocarbons, or for certain things. So, and in addition to that, I would like to mention the fact, even if they are not very good news for you, perhaps there will be taxes. I mean, we already have some taxes on some refrigerants in some countries. There will be taxes and higher prices for the energy. So it will be also a driver of the evolution of the technologies all over the world. So, of course, what I tell you is perhaps not good news. You will have more regulations, more constraints, perhaps more taxes, but it is challenging, and it is necessary for engineers to be more involved in order to propose better designs of the equipment, because you have to think about the whole systems. Jakub? Well,
yes,
I
I'm
can
with
continue
you.
if you like, but
No,
it's
good.
short.
No, because it's just an introduction where we are going, and then we will keep talking and coming back. And also I just want to tell all the participants that we already have almost above 100 participants in our refrigerant review until now, and the number is increasing. So we are capturing the questions, and I'm taking the question with Salinder like this. Then we will interact with the panelists. Now I will give the floor after the regulation and after the sort of energy and trend and refrigerant. The second thing that any developer want to act and look to is the architects, the designer, the program designer, where it starts in the beginning, that if you find a regulation, you find the sort of things, issues that you need somebody to design it for you and take care of that one. I will give the floor now to Dr. Mu'taz. Dr. Mu'taz, you have the floor, and as I mentioned, you will have between 5 to 7 minutes just to start an introduction, and then we will complete with this one. Thank you, Dr. Mu'taz, you have the floor.
بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على سيدنا رسول الله. Good afternoon, good morning, good evening, everybody. It's my pleasure to talk today about the refrigerant transmission webinar. I will share with you our experience in the program development of the central area in Medina. This mega project is a very high density project in the small area surrounding the Prophet Mosque. It's the area of the central area is about 2 square kilometers with a diameter of 1.6 kilometers and a perimeter of 5 kilometers that contain that include 400 hotel towers. Most of them are hotel towers serving the mosque for the mosque visitors in Medina. Our concern at the beginning of the development 20 years ago, more than 20 years ago, 3 things. I'm talking outside the box, you know, but these things related also to the air conditioning, related to the refrigerant transition. At the beginning, we have 3 concerns, which is the power transmission plants. We are limited. We have only 2 power transmission plants. If we will go with the conventional systems, we need maybe 4. This is one concern. The other concern was related to to the high density area. We have about 400 towers that accommodate 300,000 people. You can imagine how much is the capacity for having this amount of population in very small area, 2 square kilometers, in a high-rise buildings that have 12 floors up to 16 floors. So you have to take care of, for this high-density population, all the issues related to the environment, to the safety, and also to the efficiency. The other concern, or the third concern, is related actually to the urban fabric, the architectural looking of the area. If you go with the conventional AC systems, then maybe you will face, kind of pollution, visual pollution, when you look at the building with all the conventional system like window types and the system. So we have to consider that the urban fabric, the urban formation of the area is very, very important to us in order to have a good community surrounding the profit most. So in order to tackle all these concerns, actually, we have a customized regulations to the central area. Anybody want to design, want to make a project development, he should follow these guidelines, construction guidelines. He should follow this building codes that is customized to this area. And it is the resource of this code is for sure the ASHRAE, NFPA for firefighting, International Building Code for this for the structure, and also for electricity. So it should follow the international building codes, but at the same time we are customizing the regulation to fit or to fulfill these 3 concerns I mentioned in the beginning. So what we have done actually in putting in a building code is a figure in order to design the electricity load. You have to consider is 160 watt per square meter. 160 watt per square meter. It was is a way in order to force investors, stakeholders to go for unconventional system, to go for centralized system, to go for efficiency systems. And when the Montreal Protocol came in the 1980s, at the end of the 1980s, it was good for us to respect this protocol and forcing, putting restrictions to everybody to follow the protocol of the Montreal and to fulfill the requirements of this protocol during the years. So 160 watt per kilometers gave us the chance for the designer to come up with unconventional system like VRF, centralized chilled water system, avoiding the conventional systems of the DX and the split systems and the window type, which is almost good for this kind of projects, not good for the concerns I mentioned in the beginning. So also we have done a study in order to achieve the efficiency, the most optimal efficiency rate to achieve the environment regulations. We found out the district cooling is the most optimal solution for this area. But at the same time, development is going on. So we face some politics, issues related to how to get permissions and to excavate roads and to do infrastructure. So we consider this in the future development, but at the same time, all the towers, when you look at the urban fabric, you will see very nice looking architectural facade. You will find very high efficiency with most of the building go for the VRF, volume refrigerant flow systems instead of the conventional systems. So I believe we tried this experience, gave us the chance for future, inshallah, development to follow the best standards and to go with the district cooling in the new development coming on in the next future, in the next 5 years future. Thank you very much. I wish that I fit with the time.
Thank you very much, Mr. Dr. Mu'taz, and really it was an interesting to understand the situation of urban city and now high-rise city and the new city buildings and design. We will capture the Q&A in the later stage. Thank you very much, Dr. Mu'taz. So you can mute your mic now. And now we will go to the most promising issue that everybody is calling, and the environmental issue that we need to transfer to beyond the conventional air conditioning unit and systems, and to start choosing and going to a wider scope of technologies rather than equipment. That we giving the floor now to Mr. Ibrahim, Engineer Ibrahim, to talk about the district cooling and the type of refrigerant and how they concern with the safety issue and also the environmental issues in relation to the district cooling segment in the GCC country. Engineer Ibrahim, you have 5 minutes in your time, so please, you have the floor. Start. Thank you.
Thank you, Mr. Yaqub. I'll start continuing what Dr. Mu'taz was saying. With the relatively high cooling load requirements in the Middle East region and the huge developing which is happening right now in countries like here in the GCC, Saudi Arabia, UAE, and Egypt, including the refrigerants in one central district cooling plant rather than scatter it into individual units, is one of the key points which encourage governments and organizations and authorities to mandate district cooling for certain development sizes. This is in order to reduce the risks, the environmental risks, by being able to design the chiller vessels in accordance with the ASME codes, the refrigerant recovery systems in accordance or in compliance with ASHRAE 15. The amount of refrigerant inside the DCP is less than if you consider standalone units. For example, if we have a development of 1 million square meter GFA with a 25,000 refrigerant tonnage, this will be almost 20,000 kilogram of refrigerant inside the DCP. If you go to the standalone system, you can go up to 34 kilogram in refrigerant for the individual units. This is because, of course, of the technology and the diversity factors in designing the district cooling plants. Of course, defining refrigerants with low GWP and ozone depletion potential, ODP, is essential in designing the district cooling. The two major refrigerants utilized in the DCPs by the chillers manufacturers are R134A and R1233ZD. If we take a close look to compare between them, R134A is an HFC with GWP of 1,300 and ODP of 0 and atmospheric life of almost 14 years. In comparison to the new R1233ZD, which is an HFO with GWP of 1 and ODP of almost 0 and almost also 0 atmospheric life. One of also the encouraging points of specifying R1233ZD is the negative pressure. It's a negative pressure gas, so the leakage from the same from the equipments will not be most likely to happen. This is why it's mostly recommended, but unfortunately, due to some economical reasons, some manufacturers still working with R134A. However, they are working on in an R&D towards including the new refrigerants R1233ZD or similars, because of course, as the protocols, the R134A will no longer be produced, or the machines will not be produced starting from January 2024. Having refrigerant recovery units in the DCP is one of our design consideration, of one of the important design consideration, so that if the maintenance required for the chiller or refrigerant leakage is observed through the refrigerant detectors, the refrigerant could be stored in the unit until the required maintenance or repair is completed. Design this refrigerant recovery unit is usually based on at least one chiller capacity out of the DCP size. Also, one of the important things from the perspective of the district cooling and combining the refrigerant of the whole development in one or several plants is the high safety measures that it is considered in the design of the DCPs for the emergency cases, including the refrigerant relief piping to the outside of the building itself, the refrigerant exhaust fans, which intakes from the low, and ensuring that the make of fresh airs for the people working inside is maintained. So that's all about it. We encourage that in the future development that the authorities and the government take more actions in regularizing the district cooling in this sector.
Thank you very much, Dr. Rahim. And as we have listened very carefully to the issue of the district cooling and the must and the need of the district cooling in our region, and especially of this parts of the world, whereas conventional air conditioning become very difficult to be used, especially when you are going to the almost high-rise buildings and new cities, compound cities, which is make it very difficult to connect a huge number of typical air conditioning unit above roof or small places, so we can control the environment and the place. Thank you very much, Engineer Ibrahim. And now, before we go to the second one, I just want to thank the plenary. We will jump now to the sponsor recognition ceremony, and then we have like a presentation from that one, and then we will go to the Q&A. So bear with us now so we can complete and conclude. I already received almost 10 questions that I take care of them, and then I will raise it to the panelists to answer some of these questions, and also I have some answers to some specific question that I need. So now I think Serinda, if you want to go with the sponsor recognition ceremony.
Yes, thank you, Yaqub. And it gives me great pleasure to introduce to the panelists and to the delegates my colleague Frederick Paye, who is the co-founder and commercial director of CPI Industry, to give the sponsorship recognition ceremony address. Frederick. Frederick, you can start speaking and you can unmute. I'm sorry, you need to unmute.
Although not in person, unfortunately, for this fourth edition of our refrigerants review webinar. Thank you very much to everyone who has participated from many places in the world for their support. It's a pleasure to see you all. I want to thank you very much for your contribution today. Now, I would like to share with you a few slides, if you allow me. I would like, obviously, first and foremost, to thank our sponsor, our bronze sponsor today, Brothers Gas, along with their brand of freeze refrigerants, as well as our strategic HVACR recruitment partner, carriersbay.com. Now, if you allow me, I would like to have a few words about Climate Control Middle East and its digital platforms. As you may be or not be aware, we are actually celebrating this year our 15th year anniversary. and it's quite an achievement for obviously a B2B printed publication. Despite, you know, we just concluded the readership survey, and it turns out that very much the printed platform is very much in favor with our readers as opposed to the digital platforms, even though they are experiencing obviously an obvious growth in these COVID times. So I would like to invite you to at any time to visit our website, main website, which is climatecontrolme.com, which is mainly news driven. We also have the newer platform now, the global one, climatecontroljournal.com, which is divided in geographical areas. And these are samples of our digital issues. Basically, what has made our strength over all these years is basically the integrity of our editorial, which is again the respect of all our readers. You know, all the articles are carefully edited, and our adherence and objectivity and ethical media practices are foremost. This is what has made the success of the magazine over the years, and you can see on the screen a few samples with key articles and features that are of the past and more recent ones for this year. And obviously, this is not forgetting our guides and directories, which are stronger than ever. We have the main one, the Climate Control Guide and Directory, which is also available online, of course, which is a big database of all suppliers of HVAC, a small also section of refrigeration ones in there, which is available also online. And we also have the Refrigeration Buyer's Guide, which will be out this year, the new edition, 2020, hopefully at the Gulf Food Manufacturing Exhibition in Dubai in November, which is still, by the way, scheduled to happen, hopefully, as we are allowed sooner than later to resume physical events. Now I would like to take you through our series of upcoming webinars. We have one actually on Sunday featuring smart HVAC systems, so you are more than welcome to join this one as well, of course. Followed by one focused on disinfection systems entitled Disinfection 360, which will happen on the 23rd of July, which is next Thursday, at 9:30 a.m. our time. It will be followed on the 10th of August by the Heart of the Matter webinar, which will be dedicated to pumping systems. And then we will have another one on the 20th of August, a global event again, entitled Vaccine Virtual, focused on the transportation and safe cold storage of vaccines, which is obviously a very much trendy topic at the moment. And we shall conclude the year, our events year season, with the 10th Annual Control Awards 2020. And you can check the new categories very, very shortly indeed, which will be announced on our website. So that concludes my session, and thank you very much for listening. Enjoy the rest of the event. Thank you very much.
Thank you very much, Frederick. It was nice seeing you. This is the first time to see you on camera. We usually have self. Thank you very much, and really, it is an interesting issues that we will discuss in the future within the CPI. Thank you very much, Frederick. And now we will jump to the presentation by Mr. Sayed Shahriza in the name of Natural Refrigerant and Global Availability. Just to introduce Mr. Sayed Suhail Riza. Sayed Suhail Riza is the Division Manager, Refrigerant and Chemical at Brother Gas. He is a corporate professional with a more than 12-year track record of achievement in role and adverse as a business management, contract project engineer, and product development. He is currently the leading independent supplier of refrigerant gases and specialty chemical to the GCC and MENA market. Mr. Sayed, you have the floor, please.
Thank you, Mr. Yaqub. Assalamu alaikum. Good evening to everyone. Hope you're good. Thank you for this opportunity, especially for climate control, to represent ourselves and our one of the refrigerant review about natural refrigerants. So I would like to introduce myself. First of all, myself Syed Suhail Raza, working as division manager in Brothers Gas as refrigerant and chemical division. So I just wanted to share my presentation. Just one sec. Yes. I would like to introduce my company. First of all, I just wanted to introduce Brothers Gas in this platform first time, because we were not in this platform from the long years. Being a pioneer to this gas industry, we were missing in this platform. So thank you once again for Fabric to giving us an opportunity to sponsor and give some brief about natural refrigerant gases. So let me take you for a short introduction about Brothers Gas. Brothers Gas is a local owned company. It is a concept with a total gas solution based in UAE from past 25 years, with a global reach of 7 countries, with the different business verticals and the capacity as below. You can see that we people are, as a gas company, we are on the gas vertical, in that we do hydrocarbons, especially this is our major business vertical, and industrial gases and chemical, and the refrigerant gases, and chemical was the third gases line. Apart from the gases, we do also kind of business engineering for installation and pipeline and trading business. Brothers Gas has a capacity with 1,000 plus employees and 300 plus vehicle distribution network in local UAE, and storage capacity of 1,000 metric ton and 300 ISO owned by Brothers Gas for the global business. Coming back to the point for the natural refrigerants, that majorly as Francisca and Mr. Edgar has highlighted about the natural refrigerants, which is basically the trend has already changed, and people have started from long back, and the units are already in progress in European market, Asia market, CIS, and as well as Middle East market. So as everybody knows about the refrigerant gases and the natural refrigerant, which is existing naturally in the environment with the zero ozone depletion and very low GWP. So few are the common refrigerant gases units being sold and being used in the globally, which is one of the in the Europe part, it is 744 and 717 for the Asia region. Both the gases are commonly available with the globally in the industrial gases companies available on the different continents and the countries. Coming back to the ammonia R717, which is again the one of the natural refrigerant, and many availabilities are available globally. When we talk about the hydrocarbon refrigerant, which is taken by the whole upcoming trend for the especially domestic and international domestic segment, commercial segment, and the refinery segment, which is highly recommended due to its low GDP, which is R290, as gentleman Mr. Arkan has explained about the units, which is of his experience. So these gases are available. The units are available in the market, but many of the industry people as a gas company, we got to have some information, and we got some inquiries on the availability of the hydrocarbon refrigerants. So with that option and looking into the global environment and also the eco-friendly, Brothers Gas, they have taken some kind of decisions to go with future natural refrigerants, since hydrocarbon is highly flammable gas, and it is not easily available in the global market because with many challenges and the regulations, like example import restrictions, storage permissions, and the transportation. Because since it is highly flammable gas, so people for the guys who are trading in HFCs, they find a lot of difficulties to get and cater to the market to the market of HVAC industry. So with this, we Brothers Gas has taken an initiative to cater the global market with hydrocarbon gases supplies with our brand called Freeze Refrigerant, which is already approved from one of the European compressor manufacturer, Gamco and Froster. So we are helping with the different platforms, like with help of Brothers Gas Fulfillment Center, freeze distributors appointed in Middle East, Africa, and the Asia market in upcoming years with the below packaging, like canisters, disposable, refillable, and the bulk ISOs for the refineries. Some of the projects which we have already done in the last years to support the supplies of hydrocarbon refrigerants are like Coca-Cola. They were started with recently with the vending machine. They have replaced with R134A. So we have supported them in GCC by supplying our hydrocarbon refrigerants. EPTA, of course, again, one of the commercial leading company, MCFP, Froster, and Gamco distributors who are already available in the market, and as well as the Everest Sharjah Industry, which is one of the known manufacturer for the domestic and the commercial refrigerators. So with this, we are here as a company, as a hydrocarbon company, to support eco-friendly environment in the hydrocarbons refrigerant globally. And we also welcome global partners to work with us in this contest. That's it. Thank you very much.
Thank you. Thank you, Mr. Reza. It was an interesting about refrigerant and the movement of refrigerant in the region. Distinguished delegate and panelists, we have some sort of questions and answer that we need to answer. So I will give like in 20 minutes for the question and answer. So I will raise the questions that I get, and maybe Serinda later will follow with some question that was not captured by me. So the first question will go to Didier. Didier, the question is, do we have a standard that specify the use of refrigerant and specify which is refrigerant is more efficient, energy efficient than the other? Do we have such kind of these standards? Thank you. So Didier, could you answer this question, please?
Well, yes, I'll try to answer to that question. First, there is no unique solution concerning any kind of application, including the various kinds of applications in the cold chain. In the cold chain, you have the factory to make the product, you have the transport, you have the storage, you have the commercialization, supermarkets, for instance, you have domestic refrigeration, and for each kind of the steps of the cold chain, you have different needs and different kinds of solutions, technical solutions with different kinds of refrigerants. For instance, for domestic refrigeration, you perfectly have hydrocarbons, which it is perfect, and it is already used in some regions of the world, replacing HFCs. But hydrocarbons are not adapted to other kinds of equipment if you have some centralized systems without any secondary loop. So it is not possible to give you a unique answer. At the contrary, it is possible to have a list of the possible solutions. And I would like to encourage you to download, it is free of charge, some cold chain briefs, 5 cold chain briefs with the five different steps of the cold chain, which were published. It is a joint publication, UNEP and IIR, United Nations Environmental Program and International Institute of Refrigeration. It is in French, in Spanish, and in English. You have the, absolutely not in Arabic, but in all these 3 languages, it is free of charge on our website or on the website of the UNEP. So it would be too long to explain the various kinds of solutions, but you have the answers.
Thank you very much, Didier, for that explanation. I hope it's taken into account. Edgar, I have one question for you. It's raised by our colleague, one of the distinguished participants, saying the volume per square meter for using 290 in a supermarket. In Brazil, they have law or regulation about how much charge of limitation charge in the square meter for using such kind of 290 in a supermarket or cooling places.
Yes.
Edgar, you have the floor.
Thank you very much. We are using ISO 5149, and it depends on the place where you put your system. If you put on the roof, or if you put in a charge machine, or in a machinery room. But you can have around 5 kilos, depending on the situation, 20 kilos of propane in a system. And to reduce this charge, we have developed the modular chillers. So we have low charge in each system, in each circuit. So it's a way to install, like if I need to install 10 kilos of propane and I have 10 modules, I have 1 kilo in each module. So my charge is 1 kilo for each module.
Thank you very much, Edgar. I think that will clarify that amount. Mr. Ibrahim, there were a question regarding to the district cooling that it's been raised, that raised from our colleague. I will raise the question and what is the minimum cooling load in ton of refrigeration for the design installation of district cooling in the term of economic value and efficiency? So Ibrahim, if you can, and also some people are looking to find in the presentation, if you can share with them a spread data sheet of that presentation that you have. Thank you. Ibrahim, you have the floor.
Yeah, for the cooling load and the economical value, it has to be considered based on each and every development. This cooling system itself based on high intensity load distribution. For example, if you have a lot of towers and a lot of high demand buildings, you will need to have a district cooling to feed them. If you have a compound full of villas on a huge square meter of land, this might not be visible. So the thing is, a district cooling or a district cooling system study should be done from a feasibility point of view with the different cooling options based on how long will be the chilled water network extended, and comparing this with electrical cable distribution cost versus cost, operation costs of the individual systems versus the cost of the operation of the district cooling plant. Also, the diversity considered in the district cooling system regarding the total capacity of it versus the capacity of the individual units. So you have to start by studying the capex of these two options, and based on a life cycle of 25 years, you have to study the operation costs in terms of electrical consumption, in terms of water consumption. What are the options? Are you going to use TFE water for the cooling towers? Are you going to use seawater? The restrictions of the water at the country, the regulation. A lot of things has to be considered in the feasibility study at the beginning.
Thank you, Ibrahim. There is one more issue that if you can highlight it before I go to another question. The question was does the regulation mandate to go for a district cooling in UAE? If so, are there any certain requirement in UAE to use district cooling?
Yes. If you are a developer and you are going to your demand load is more than 5,000 refrigerant ton, it's a mandatory to have a district cooling plant in the development in this development in UAE. The requirements are you have to submit first a feasibility study to the system proposed, the request for the electric connection for the authorities. In case of Dubai, for example, it's DIWA, because at the end of the day, if you have a bigger development without a district cooling plant, you are wasting the energy which will be produced by the government as in terms of electricity. So that's why they limit the development size to 5,000 tons. If you are going more than this, you have to go with the district cooling system.
Thank you very much, Ibrahim. Dr. Bakhit, we have a question raised to the concern that as you are presenter from Saudi Arabia, that the sister kingdom in the G20 in 2020 and 5 years, the energy efficiency leading program compromised several cooperation dedicated to the promoting of energy efficiency in the cooling and on end-use equipment on building fuel. There was even a proposal on district cooling. So do you have any information that they will reinforce this one or any programs in the Kingdom of Saudi Arabia now for initiating or enforce the use of energy efficiency cooling?
I believe the high authority of the electricity, they have a plan in order to, enforce whatever systems bring more efficiency to the buildings. One of the 2030 vision requirements is to improve the efficiency of having different engineering systems. So according to the high authority, they are now in a plan to insisting and to regulate rules that lead to high efficiency of AC systems and electrical systems, especially, and also architectural. They are now concerned about the insulation in the building, concerned about the green building that have double glazing, triple glazing, in order to avoid the heat inside the building. They are forcing, for example, in the central area, we are giving a percentage to have a glass in the elevation in order to have more solid than void, in order to reduce the amount of air conditioning required, load of air conditioning. So there are so many rules, I think, right now going on in order to improve the efficiency and environment requirements.
Thank you, Dr. Bakhit. Francisca, there is a question regarding to your presentation that the EE decrease is due to the shifting from HCFCs to CO2, or it was a little bit affected by changing an old unit to a new unit and its performance?
Yes, thank you. Now that's a very good question. And just to answer that briefly for now, and then I go into more detail. The setup of this demonstration project was that we are converting an old system in an existing supermarket, existing system to this new CO2 transcritical technology, which then of course will also cause some of the energy efficiency reductions that we've seen just being based on being an old system. However, since this is just one case and one project in a country, we could not unfortunately cover, you know, all the cases. How would it be to compare it to a new HFC system, to a new HCFC system, and so on. But I think what is important and what was also the role and the purpose of this project is to see if such a system is working in the country and in the also with these temperatures, and see, compare it with the old system that was there before. What are the advantages that we are expecting? I would like, if I may, just for 2 minutes, because I've seen there were also some other further questions in regards to the technology use and the setup and so on. And maybe I can just share my screen for a second.
Yes, please.
And because we have an online website, open.unido.org, where we have all our projects that we're working on. And there is also detail, and I have the link in my presentation that will be shared with all of you, I assume, here for the Jordan project. And there you see on the right-hand side that there is a final report, that there's also a summary brochure. And for example, the brochure looks like that. Do you see the brochure, Jakub? And
yes.
Good, very good. So here you see there's a bit of an intro in general about the cold chain and the importance of the cold chain, about the project. And then also we go into detail of all of the components of the system set up in specifics. What are the ejectors that we are using? What are the display cabinets? Then also, if you scroll to the end, sorry, again, I'll just try to keep it brief right now, but you can find all the information if you're interested in, you know, to see the differences of the systems. What is special about such a CO2 system? What is the specialty about using the multi-ejectors? What are the technical details? What do you need to know also when you change to such a system? And also the energy measurements and performance measurements over several months period that you can find in there. Then we have also, as further material, the final report of the project. I'm just quickly skip through that now, where you also have much more details than what I was able to tell you right now in the short time, and where you can also find details of how the supermarket looked before, what are exactly the energy efficiency and the energy results that we are having. Wait, sorry, I'll scroll a bit faster to the end here, where we have also the environmental impact exactly analyzed. So all of this you can find on our Unido platform, open.unido.org, just to advertise for that again, and all our other projects as well. And one other quick point, I think it's important. I mean, I understand, of course, and I worked in the private sector before. So the business case is very important, and we have to see if we can save money. I totally understand that. However, we also have to see what are the alternatives. And I mean, with the Montreal Protocol, we basically don't have the choice of having a new HCFC system installed. And also, I mean, with the Kigali Amendment in Action, as you can see here, there's also discussions about the HFCs, and especially the high GWP HFC. So we have to see and look at all the different alternatives, and see if you want to, you know, also be smart in your choices for the future. What is really future proof? What if I have to change, you know, my system again in a few years? What makes more sense on a long-term basis, not just for the environment, but also for my wallet, for the money. Thank you.
Jakub, may
I
add something?
Yes.
Jakub, just to add something.
Didier, before you add, take this question also on your mind when you are answering. There is a question in relation to the HFOs and the efficiency between HFOs and 134A comparing volumetric issues. So please, if you consider to answer both of these issues.
Okay, well, I wanted first to mention the fact that if you only change the refrigerants, and it is true with HFOs compared to CO2 or other refrigerants, high global warming potential refrigerants, if you compare the efficiency of such a change without changing anything, a part of it, you will not have a good result, except the fact, of course, that you will have less emissions in CO2 equivalent. And the example in Jordan is typical. I mean, if you have such a better energy efficiency, it is because you have a lot of other changes within the systems. And we are currently reviewing a report we are writing with UNIDO, thanks to a contract we had regarding especially the retail sector, explaining the different possibilities you have to improve the energy efficiency of the global system. For instance, only simply having glass windows in the supermarkets, then it is, of course, much better than having directly the food in front of you. Things like that are very important. And once again, it is very important to take into account the energy now, because the main challenge is climate change. We have to take into account the energy efficiency of the whole system, not only of the electrical equipment itself. It is not very different if you change HFOs compared to other one. It is not enough.
Thank you very much, Didier. And I think I captured almost all the question that has been raised to the floor until now. We have some minor question that it's need a specific answer and a specific approach. But I just want to raise an issues that I have. I will cover that one, so I don't see any problem.
Yaqub, if I may add, there's a question for Francisca, and this is coming from Chitrananda D. Alves, who is the Director of Engineering from Shangri-La Hotel Group in Dubai.
Yeah, okay, you can ask her the question. There is okay. I was looking to that question. It was big, and I want to send it to her in a short way. Okay. Francisca, you have any questions? So please.
Yeah, sure. So the question to Francisca is, she mentioned CO2 system CapEx is higher than OpEx. CapEx is higher and OpEx is lower. I would like to know what could be the ROI of such a project which was completed in Jordan.
Yes, I'm just sorry. In parallel, I hope you see that I copied the link in the Q&A chat for the UNIDO, and yeah, and you will also find it in my presentation. That is a very good question. Also something that we could not specifically cover in our project, because the setup is that it is a demonstration project. It was the first system in the entire region, and you can't compare a first system and a first in any technology that you're using to like the economies of scale system that you're using. So that's why the question for the return on investment is also a little bit tricky one in general for our project. For example, the security measures that went into the system, like special valves, special safety valves, pressure valves, also an additional a bigger compressor rack that was used, was just because this is this first type of demonstration project. So you can't really compare the cost of such a system with the normal system, how we could use and apply it. I will also send you a link in the chat in a minute, because I was actually looking at numbers and cases and trying to find the actual return on investment figures in some case studies, because well, maybe I can just share again my screen. For one thing, there is also, publications and CO2 transcritical installations in the world. And just to give you an idea, that we have already over 30,000 installations, of course in different climate zones, but also when you already look here around, you know, South America, Central America, Mexico, here, our Jordan there, but also in India, Malaysia, Taiwan, China, Indonesia, Australia, also in South Africa, actually already over 220 CO2 transcritical supermarket installations. So there is evidence, and the system is used in specific cases. I can't give you a specific number and year for the return on investment, unfortunately, because it just depends too much on the situation, on the size of the supermarket, also how integrated the system is. Because the future, and I think the real beauty in a CO2 transcritical system lies in the using an integrated system, meaning also applying it, integrating also air conditioning. If you are somewhere in a cold country, you can even, you know, use the waste heat to melt down your snow outside. You can use the waste heat also to heat up your water, as we're doing here in Jordan. So there's many opportunities, and this is, I think, just a starting point. And what we have right now already there, even though there are already 30,000 systems in the world, is just the beginning of the technology, because it is still much more to develop there. And I'm sure the energy efficiency will go down, the price will go up actually, and the prices will go down of such systems. And then we can properly discuss also the return on investment. I hope that kind of answered part of your question.
Thank you, Francisca. I think it's covered. So, Surinder, do you have any more question?
Yes, it's more of an observation, I think. This is coming from Antonio. I'm not sure if I'm pronouncing this right. Antonio de Seca. And he says, in Europe, we see many suppliers moving towards HFOs for district cooling. But some countries like UK, ammonia is also being used in district cooling. I don't know if anyone would like to comment on this.
Well, I would like to comment the following thing. District cooling is already implemented for years in Europe, for instance, in Paris, Marseille, Stockholm, and so on. So it is also in Hong Kong. You already have a lot of examples of district cooling all over the world with various kinds of refrigerants. I don't have any comparison between HFOs and other refrigerants regarding district cooling, but it is not the main issue. The main issue for district cooling is the fact that you use a source which is as a determined temperature. It can be a river, it can be a sea, it can be the soil, and in order to share all the system to various buildings and to optimize the global system. But I don't know if there are some examples with HFOs. There are other examples with other refrigerants, but I think that the main problem is not that one. The main problem is to convince a community, a town, to organize a shared equipment. I would like also to mention the following thing, which is totally different, but which was not mentioned. It is the occasion I have, just because I have the possibility to speak. Don't forget also the possibility to use renewable energies. I mean, solar energy, for instance, in your countries. There are more and more demonstration projects using renewables, including the problem of energy storage, and you have also technical solutions for that. So don't forget that. It is also another way to reduce climate change.
Okay. Can I just ask a few more questions, Jakub, or do you have something?
Yeah, you can.
There's a question coming from Marco Buoni, and he says, competence of technicians, certification, handling new refrigerants, which are mostly flammable, has been taken into consideration in the projects of the panelists and in other projects based in Middle East. So he's asking that, have these been taken into consideration, the competence of technicians, certification, and so on. So I suppose this is a question as much to Francisca, to Edgar, and to anyone that is handling handling refrigerants that are mostly flammable?
For our project, they took it in consideration. They trained some technicians to handle it in the factory. And the concept of the project is to bring the defective unit to the factory. But of course, there are some technicians trained to handle the propane, the field. But the concept of the project is to charge and service the equipment in the factory, do it to the high charge of the propane, the systems. Thank you.
Maybe just quickly for our project. So CO2, the issue here is the high pressure that is used in the system, and in the system, sorry. And of course, yes, there was a training. It's very important to bring the higher engineering of such a rack, actually, to bring the attention of the technicians and the engineers. And there was an exchange between the Italian manufacturer and the Jordanese company. But what we've seen is really that the basics of the engineers and technicians that we had in Jordan was really impressive. Very eager, everybody is learning, wanting to learn this technology. Sorry, there's a little bit of a disturbance in the sound, but I think it's fine. And there's also in parallel programs that UNIDO and other implementing agencies are doing, by the way, also with Marco Borni, who's asking the question, to certify and to train technicians and engineers. Very important point. And I think this is also one of the main focuses that we have to give in the future, the training and the education of the service technicians, of the engineers, of the installing companies, and so on.
Jakub, you want to ask questions? There are a few more that have been posted. Do you want me to ask those questions? You're on mute, Jakub.
Yeah, so I think there was some question raised that I need to answer it very quickly for the people, because there's a question about the blowing agent for the foam sector. I just want to highlight that all the manufacturing in the foam sector already has been transferred to a non-ozone depleting substance and also a non-HFCs alternatives, and it was funded under Montreal Protocol. I have 3 factories in Kuwait for XPS and 2 factories for polyethylene, and we have 2 factories in Qatar. We have in Saudi Arabia, and I think in Oman, 1 for heating waters. So I think for the foam sector has already been transferred to natural refrigerant or cyclopentane with MDI or CO2. So that sector was totally being covered, and the efficiency and the outcome of this result was very promising. And I think you need to have also some information about it in relation to this development. And also we have like water-based issues also is being investigated and show promising issues. This is just a question related to the foam blowing agent. I have one question was asking about 1, 2, 3. I just want to highlight that 1, 2, 3 is falling under the basket of HCFCs, and it will be in phase out very soon. So demanding or aiming to have that refrigerant anymore is like throwing your money in the horizon without getting anything. So yes, that refrigerant can be, if you have a machine and you are using it, you can keep it for the new project, for the new installation. It is not recommended, and I don't think there is any more manufacturing equipment in relation to 1, 2, 3 as Kigali Amendment put and accelerated phase out of HCFCs has been done. So I think these to be covered. And also there was one question in relation to the regulation and forcing Kigali, like in what's happened in EU. I just want, as a government representative and as I am the coordinator for my brother in the GCC, that yes, we are in the Kigali group, and yes, we are supporting, and we joined the board in Kigali Amendment, and yes, we are supporting. But in our region, this is why we have the refrigerant review, that there is big sectors that using HCFCs and HFCs to be transferred to a natural refrigerant or climate-friendly refrigerant. So one of the case study that why we are not aiming on the refrigeration sector, domestic refrigerant, refrigerator, domestic freezers, water coolers, supermarkets, all these can be tackled and can. Also, we targeted the foam sector. And this is give us a big chance that we are removing and doing leapfrogging from HCFCs. Without going to HFCs, we are jumping to natural refrigerant. And yes, the GCC is now updating their unified GCC law regarding to the ozone depleting substance in Kigali. And I think very soon, within a few years, you will find a unified regulation to support the use of natural refrigerant and how to use it. But taking into consideration that the infrastructure of safety technicians and the safety chains for using these refrigerants have to be also updated and taken care of. It's not just a decision to be put on the ground and that's all. It will affect the safety of the life of the people and parameters and buildings. So we have to be very careful, and we are moving in that regard. And also we have the support of the UN agencies, UNIDO, UNEP, UNDP, World Bank, bilateral agencies like Germany and Japan and all of these people. So we are on the track in the GCC, and we will follow up with the world, and we will do as success story as we done previously. Thank you for. I think if there is anything to be covered, Surinder, as a question.
There are a few comments.
Yeah.
This one is coming from, sorry, I'm just scrolling up, so bear with me as I scroll up. This is coming from Andrea from EPTA, and he says, CO2 is already implemented in UAE too, in Abu Dhabi, in a Carrefour supermarket in Masdar Sustainable City. So that was an observation from him. And then he goes on to say that, speaking from a client's perspective, they are interested about energy saving, but it is not enough. What can really push a real change in the client's mind is going towards green solutions, is an implementation of a regulation in Middle East banning HFC refrigerant, as happened with the implementation of F-gas in Europe. Do you see any implementation of strict regulations stricter than Kigali in Middle East region? So that's a question from Andrea of EPTA. And yeah, so who would like to take that? Would you like to comment on it, or
I will thank her for the questions, and I just want to say, and I think Francisca and Edgar and my colleague, which is working with me on the Montreal Protocol, will understand that stringent than Kigali, we were 196 countries that set for almost 6 years to reach to that agreement as a Kigali agreement, to sort of to do the best thing that we can do in the relation of taking out HFCs. And we take in the consideration that there is a developing countries and there is a developed countries, and that transition from technology to technology is not an easy issue. It's not just like clicking your 2 fingers and things will happen. We have a lot of sectors in the GCC, we don't find solution yet for it, and we have to be very careful about that. Didier also mentioned that we are updating the standards and the safety issues. ASHRI is doing their studies. There is a platform that it's growing to reach to the maximum that we can achieve. And just to make sure, and everybody understand, that the Kigali Amendment is not a phase out amendment, is a phase down. And when we say phase down, it means not we will reach to the zero consumption. No, we will move 85% unless we find the solution for the 15% that we suspect to be for a longer time. So we are in the movement. Whenever we find the solution, equipment, technology, refrigerant on the ground, economically feasible, friendly use, believe me, we will accelerate the phase out of these things as soon as we can. our aim is the safe of this planet. So in Montreal Protocol, we always do these things. Thank you.
Yes, Francisca, you have a comment?
Sorry, maybe just to comment on that. And yes, I mean, totally agree with Jakub, and the Kigali amendment was, I mean, Montreal Protocol in general is a success story. And I think the Kigali amendment is also a big step and was difficult to achieve. However, 196 countries agreed to that. So that's the common ground. It doesn't mean that other countries or countries that are more progressive can go ahead faster. And it leaves the possibility, and we are there to support. And there's also the Montreal Protocol multilateral fund to support these fast actions, these early actions, these pioneering companies and initiatives and companies who want countries and companies who want to be involved, because I think it's also just to have out a little call for action, because I think it's important for the competitiveness of a country and of an industry to be ready, especially in the manufacturing sector, to be ahead of the curve or to be part of the of the innovation. And that's what I've seen in many countries that we're working with. The countries want to be the innovators. They don't want to take too much risk. This is also understandable, but there are countries that want to go a little bit faster, and this is possible. And this is what we are trying to also support and show here in our examples.
May I add also something, Didier Coulon? Well, I totally agree with that. And I would like to mention the fact that now refrigeration, including air conditioning, is a priority at an international level. And you had a lot of declarations last year from the United Nations. There will be also, and there was last year, a declaration of the G20, for instance. So refrigeration is a priority because it is necessary for life, as well the cold chain for life, the health issues with vaccines, the problems of air conditioning in hot countries. So it is a priority, and at the same time, you have to reduce the energy consumption because it is fast increasing. It is skyrocketing. The use of air conditioning is skyrocketing. There are a lot of needs regarding the cold chain for food and health products. So in any case, we need a sustainable development, and it is a priority. So in any case, you will have not only to respect the Kigali Amendment, but if it is possible, to do more than that now.
Okay. Surinder, you have anything?
No, I think we have run out of time, to be honest, and we have some more questions, but it's past 6 o'clock, and we said we would close at 6. So I suppose we'll have to wrap up, but we will address these questions in the magazine and Climate Control Committee's magazine in a subsequent issue.
Yeah, so I think we capture a lot of things. I just want to join with you to thank our panelists and for their time, for their knowledge, for their share. And I think I gain a lot of information and things that it will highlight me when I negotiate in the future, that it gives me a competence to go move and to negotiate the deal of these ones. And I will thank all the audience that attend with us today within this time to attend and listen to us talking about things that it's very important to our region. In the wrap-up, Surinder, I just want to say that as the distinguished delegate, my colleague Francisca and my friend Didier, the success story always starts with a teamwork that everyone achieve more when we work together. So on the governmental side, on the environmental treaty side, on the agency and implementing, and also we have to keep in our mind the local manufacturers. We have to give them the chance to update themselves and to build themselves for the new challenges. It's not just changing the life in one sec. Just to keep everybody understand that the GCC government and environmental people in the GCC is very concerned about the type of equipment, and also we are very very, very harsh on getting the best technology and to avoid having HCFCs presenting in country whenever we can. And to just give you the emissions, the image size that UNIDO and Francesca and Edgar are doing these case study success in some countries with little bit high ambient temperature. So we understand where they are going, and then they will jump in our port, in our region, to start another success story to build. We are taking lesson learned from all these case study that it's done, and Francesca knows that we already joined these meetings and ceremony, and we see why, because we are concerned to solve the issues there. So we have to understand that the road map is very clear for everyone. As Francesca says, as my colleague says, we have a lot of solutions in some part, and we have some difficulty in some part that we have to solve. And there is a part on the market, there is a part on the government, and there is a part on the public awareness itself. The people, the mentality of people have to change. I just always say, flammability, toxicity is issue that we are living with and we can accommodate ourselves with. So why we are afraid from flammability? No, it's not an issue to afraid of, but we have to understand how to deal with it, how to make it more safer to deal with it. Now we are in a pandemic, but we are surviving because we understand how to deal with this one. So even with the flammability technology and everything, we have to understand how to deal with it and live with it. Because as the DA and everybody know that the new technologies which is coming, all the refrigerant are not the magical solutions as R22 was, not flammable, but we can deal with it, we can understand it, and then we create the technology that can absorb and reduce it to the lower minimum of dangerous to be used. Thank you very much.
Thank you, Jakub. Thank you so much for once again a wonderful job chairing our refrigerants review webinar. It's my duty to thank every individual plenary session participant. I would like to thank Dr. Motaz from the Zuhair Faiz Partnership, Saudi Arabia. Thank you, Dr. Motaz. We appreciate your participation. Didier Colomb from the International Institute of Refrigeration in France. Thank you, Didier. Ibrahim Hisham Hassanin from Allied Consultants. Thank you again for participating. Mazan, who could not join us, but he's a dear friend, and I hope he can join us for the next edition of Refrigerants Review. Francesca from the Montreal Protocol Division, Environment Department, UNIDO in Austria. Thank you so much for your participation. Of course, Edgar Soares from UNIDO Brazil. Thank you. We appreciate your participation, and also our sponsor, Brothers Gas, which was represented by Suhail Raza. Thank you so much. We have, as I said, a lot of questions that are coming in, and we have unfortunately run out of time. For sure, we will address these questions in the magazine in the upcoming issue, and we might reach out to you individually if some of these questions are directed at you. Thank you so much again, and stay safe.
Thank you.
Thank you very much, everybody.
Thank
Stay
you.
safe.
Bye.
Have a good day.
Thank you very much. Thank you very much to everyone.
Thank you.
Thanks a lot.